on Jumpstart Your Microservices Development with Java EE. And my colleague.
Hello, is this working? So my name is Kate. You may be able to hear I have quite a sore throat, so no voice. I used to work with Graham in the Liberty team, and I'm now working for IBM Cloud, working on Java developer enablement, so how can we get Java developers writing applications for the cloud as quickly as possible. So during today's talk, we will be talking about microservices. Who here thinks they already know what microservices are? Most hands. Okay, so we'll give a short introduction just to kind of set the scene and make sure that we're all on the same page. Then we'll talk about Java EE evolution, where it started, where it is now. We'll talk about Docker and microservices and why they might go well together. Some packaging considerations when you're building applications. Why you might want to use OpenAPI as part of your microservices. And then finally a conclusion. So, microservices are used to compose a complex application using small, independent, replaceable processes that then communicate with language-agnostic APIs. Hopefully you've all kind of come across them before. From the show of hands, it sounds like you have. And it's taking your existing monolithic applications that you would have had one thing that you deployed once, and if you wanted to scale or iterate, you would keep scaling and iterating that one piece and then breaking it down into smaller pieces. And this brings you a lot of advantages. There's things around being able to iterate faster, put out new changes quicker, being able to scale the different parts of your application more effectively, but of course it comes with added considerations. So you're adding some complexity because now your application is distributed, the services need to find each other, they need to be tracked in terms of like logging across the whole system. So there are some considerations there. So whenever I give a talk about microservices, I always say, no, it's not something that will solve all the problems in the world. Think about, what are the advantages and what are the concerns or the complexities that it brings when you're moving to microservices before just sort of blindly going ahead. The other thing that's worth mentioning with microservices is 12-factor applications. If you haven't heard of the 12 factors, go check out 12factor.net. All of the information is there. It's a methodology that was set up by the developers at Heroku for building software as a service applications. There's a whole bunch of different factors. They're independent of programming language, backing services, cloud provider. You don't have to follow these 12 factors if you want to build microservices, but if you keep them in mind while you're building your microservices, you'll find that you end up with better applications that are easy to deploy to the cloud, that function well as part of microservice architecture. And we'll kind of come back to a few of these as we go through the presentation. So, what to look for in a microservices environment. So first off, microservices technologies. I've already said that if you want to deploy different microservices, you might need to find the different services and have that communication between them. You might see some sort of tracing that goes across them. So you need an environment that's going to provide you the technologies to do that. With a lot of things like service discovery or load balancing across your applications, you don't need to build these things up from the ground. There's lots of solutions out there, so looking for existing technology is definitely a good choice. Because microservices are designed to be stood up quickly and easily teared down and replaced, you need to have fast startup and then also clean shutdown. Microservices should be stateless, so you should be able to take down the application and stand a new one up without having to do any sort of cleanup or putting away data into the right places before the application goes down. A small footprint is important to save you money, because if you're deploying to a cloud environment, you're often paying for how much you're using. So if you can deploy smaller applications, then that's a benefit to you. And externalizing config allows you to then deploy your applications in various different locations without changing the application itself. So by passing in the config via an environment variable or something like that, then you'll find you can then redeploy your application without changing it. we found that with microservices there comes a need to push out services more quickly and to iterate more quickly, and that's one of the driving forces behind people moving to this architecture. And with that, having development and production parity is very important, because you want your developers to be able to make changes quickly and have a very short amount of time between when they first start working on a problem and when it goes to production. And if the environment they're running locally is very different from the production environment, then there's always going to be that piece of time where you're trying to work out why it doesn't work when it did in development. So if you can get them as close as possible, then that's good. And the final one we've put up here is containerization. We'll talk a bit more later about why containerization is a good choice for microservices.
Okay, so who here uses Java EE? Quite a lot. Most of you, that's good. Who here is doing microservices with Java EE? A few less. Who here is doing microservices without Java EE? Okay, similar number. So when I talk to people about Java EE, you get the general impression that people think it's maybe not appropriate for microservices, it's maybe too slow, too bloated. And I think to understand why there's that perception, it's worth looking a little bit at the history, but then also looking at where application server environments have moved moved to over the past sort of 3 to 5 years. So Java EE is quite an old technology. You probably, given the show of hands, most of you have probably got kind of large monolithic applications running in your data centers, running on maybe one of the application servers that's been around for maybe 15 or more years. So if you look at the history of Java EE, first releases were out in the kind of late 90s. Were a small number of specifications, and then as they evolved, they added more and more specifications, and it was quite clear kind of around the turn of sort of 2008, 2009 that things were getting too large. And so what the standardization groups did is split Java EE into profiles. So created web profile and full platform. But it was quite clear also around that time that although web profile was quite useful, when I talk to customers, they say, yeah, I want web profile, but I also need this bit, or actually I need less than web profile. So just going for profiles isn't necessarily good enough. And EE has continued to evolve, and in EE8 you can see we've added new capabilities to Servlet with Servlet 4 and into JAX RS, and there's a new JSON-B specification and so on. So it's continuing to evolve. And kind of part of the problem or cause of the perception is the runtimes evolved over this time and kind of matched what was required by the EE specifications, and the EE specifications required you to support all of those things by default out of the box. However, what various vendors have done is kind of gone beyond what the specifications require in terms of supporting absolutely everything, and have evolved into more flexible environments. So a number of offerings or vendors have produced packages that are smaller than web profile, from just web container capabilities all the way up to EE, and other vendors such as JBoss with Wildfly Swarm and Swarm Fractions, and WebSphere with Liberty Features now available in OpenLiberty, have given you the ability to actually customize things further still. So you can start off with just essentially a small core runtime and then pick and choose what pieces you want to include into the environment. So on the top right, we've got an example of an OpenLiberty configuration that's just using JAX RS and OpenAPI. And then on the bottom right, we've got a kind of similar equivalent configuration in a Maven POM for Wildfly Swarm Fractions. And if you use those kind of approaches, you can end up with a very small runtime. So, for example, with OpenLiberty, you can go from anything from a 15 meg runtime, which just does web container capabilities, all the way up to a full Java EE runtime, along with MicroProfile, that's about 76 megabytes. And so the view that EE capabilities or EE environments, capable environments, are kind of slow and bloated is kind of no longer the case. But if you're looking to do microservices based on EE technologies, which I think is the way to think about it, EE doesn't really take you all the way where you need to be in order to do microservices. And there was a kind of perception within the various vendors that EE was moving too slowly. Microservices were rapidly gaining adoption, and customers were asking us about how to do microservices and what APIs we provide, and EE wasn't giving us those things. And so a group of vendors and meetup groups and so on, communities got together initially in something called MicroProfile.io, which was a kind of fairly loose collaboration, and then eventually into Eclipse MicroProfile, to start creating specifications and implementations and test cases, test kits around microservice technologies. So who here until I just said it has heard of MicroProfile? Okay, a fairly small number. That's typical because it's pretty new. But what MicroProfile does is it says we'll start with a basis of some EE technologies. So it says JAX RS is useful, of course, for doing REST services. JSON-P, so you can do processing of JSON, and CDI, so you've got a component model and an injection model. And then says, okay, with those basic capabilities, what are the new things we need that are required for doing cloud-native microservices? And so if you imagine what was typically maybe a monolithic application that you deployed once and then just scaled it out, now you've broken that into maybe tens of individual microservices that you then need to deploy and scale out. You've got a lot more things running. You've got network involved for the communications between the microservices. So you need to think about how you're going to manage those things, but also how they're going to behave in the presence of a network which might be unreliable at times, or maybe the service has actually gone away because you've now got independent teams contributing to your application, and maybe one team gets their deployment wrong and everything goes away. So there are specifications such as fault tolerance, which standardizes some of the common patterns for dealing with service failures. So bulkhead, for example, or circuit breaker. So you can do things like define retry policies, what the time interval is between retries, and if ultimately your 5 retries fail, what's the service I'm going to call as a fallback. There's configuration. So Kate mentioned the 12-factor applications. What config does is define a standard way, a specified way of getting to configuration that's specified either within your environment or outside of the deployable unit. So what you can do is you build the unit once, and as you take it through the pipeline, you don't rebuild it. Anything that changes as you go through the pipeline is externalized as environmental config. And that's what the config API gives you. And then there's things such as being able to understand the state of a particular service deployment. So health check tells you whether the service is up or down. Metrics tells you a bit about the resources. JWT gives you security. And one of the ones in the pipeline that isn't done yet is open tracing, which gives you traceability through your service requests. So if you're doing microservices based on Java EE technologies, you're probably going to want to use the MicroProfile capabilities to do that. Okay, quick demo. All right. So what I'm going to do is just, I guess, as evidence of the kind of lightweight nature of some of the application server environments there. I'm going to use OpenLiberty. If I used a different one, I'd probably get shot by my employer because I work for IBM. Actually, no, they don't shoot people. That's being recorded, isn't it? So I've got an install of OpenLiberty. So I went to OpenLiberty.io and downloaded it. It was a 76 megabyte download, and I've unzipped that onto disk. And what you end up with is something that looks a bit like this. So I've got a set of commands in the bin directory. Lib contains all the runtime pieces, and user contains all my configuration, so my application and my server configuration. At the moment, I haven't got a server, so I'm just going to create a server. So I've now got a server defined. That comes with some default configuration, and I'll just alien keyboard. And I'll just run that server. And it starts up in a few seconds, maybe a couple of seconds longer because we've got a VM running in the background for Kate's demo. Okay, so whilst that is running, what I'll do is I'll go and show you the server configuration. And so this is the server that we've got running. So at the moment it's just running JSP. And what that means is because JSP depends on some other things, it's actually, it knows about the dependencies, so it's running, it's running JSP, servlet, and expression language. So we've now got a server running, and if I've got a browser here somewhere, we can just go and hit the default landing page for that server. So there's no apps installed, but it will serve you up a page so you know it's all running fine. All right, and what I can do is, it's a dynamic environment. It knows about changes, so I can just change the server configuration. Oops. And I'll change it to just use servlets. And actually, it happened before I got back. You can see JSP pulled in servlet and expression language, but because I've removed JSP, it's now removed those features without restarting the server or anything. So I've now got a runtime that's pretty minimal, just running servlet. So I'll stop that. And so one of the things a lot of environments also provide now is the capability to package things up. So I can package this up as a minimal server, but I can also make it runnable. So if you've used Spring Boot, you'll be familiar with the concept of runnable jars. The various EE vendors also provide runnable capabilities. So I'll just package this up. Let's call it default server.jar, so I know which one it is. And then what I'll say is I want to include the minimal content, so only what's required by the server configuration. So it should only include servlet, and I'll make it runnable. And so what this does is it actually starts the server to determine what's required, and then packages that up into a jar. And let's have a look. So you can see we've now got just under 15.5 megs for an application server that can run servlets. And just to hopefully prove that that's the case, we can run it. So let's hope I can do a refresh before it's run. No, sorry, it was too quick for me, so I just refreshed that page, and you can see it's now serving from the jar that I created. So let's stop that one and go back to slides. Oops. Okay, so hopefully that gives you the kind of idea of the fact that the kind of perception that EE-capable servers are too slow and too heavyweight is kind of no longer the case, and probably hasn't been the case for at least 5 years. All right, so no microservices talk would be a microservices talk without the mention of containerization and Docker. So just a quick 101 on Docker and containers. So containers are based on a couple of capabilities that essentially help you isolate into a container the things you want to run. So they're based on namespaces. There are 6 namespaces in Linux. So things that help avoid you clashing maybe on processes or clashing on disk and so on. And then there are control groups or C groups, which help you partition up the system based on resources. So you can assign a certain amount of CPU or a certain amount of memory to each of your container instances. So the C groups thing helps you avoid the noisy neighbor problem, which we've seen in kind of traditional application server deployments where historically people would stand up a Java EE app server and then deploy multiple applications to it. And if one of those applications misbehaves, then it ends up eating the whole resources and impacts the other applications. Whereas if you're using containers and the C group's capability, then they can only grow within the resources that they've been allocated. Okay, so a little bit about Docker and why Docker is useful for microservices. So when you're doing microservice deployments, your operations that you're going to do are not everybody is going to be deploying Java. It'd be quite nice if they did, but you need databases, you need other things. So you're going to want to deploy containers that are essentially polyglots. So you're going to have multiple technologies being deployed. And what Docker does is it gives you a consistent packaging mechanism across those things. It gives you metadata for the externals, so for example describes what ports are required and so on. It has the concept of layers, which helps with in terms of the performance for building up Docker containers. So you can layer things, which it's nice because it gives you a view of the architecture of the contents of your container. So you might start with, for example, the base operating system. If you're doing a Java deployment, you'd have Java and then maybe some server capabilities and then your application. And one of the things that the layering does is Docker will cache those layers. So if only your top layer changes, then it's a lot quicker to work with because it's cached the other layers when you were doing your previous work. It gives you a consistent interface for doing things like logging and metrics and volume across the different types of technologies. And optionally, you can make your containers immutable, which means you can make them self-contained, and so that can help avoid problems as you move through your pipeline. You're not depending on too many externals, and therefore there's less risk involved as you go through. Okay. Oh.
Okay. So now I'm going to do a demo with Docker and kind of some of the things you can use if you use it with some of the application servers at the moment.
And I'm going to be a mic stand.
So I'm going to create a project with something called the IBM Cloud Developer Tools CLI. It's something you can get from IBM Cloud, but it's actually can be used to generate projects that you don't want to run on IBM Cloud. You can run them anywhere. And then you can actually build and run it with Maven. And then I'll show it running in Docker as well. And let me know if you can't hear me. So I'm running this in a VM just because I find Docker runs a little bit better on Linux than it does on my Windows. So I've already installed the CLI, and the way I call it is bxdev, so I can do bxdev create. And this will then get me some options. So it first asks me if I want to log in. If I logged in, then it would allow me to provision actual services in the IBM Cloud. So I could provision things like Cloudon or Watson services. For now, I'm not going to do that, so I'm going to say I'm going to continue without logging in. So these are some of the patterns that we have available to us at the moment, and I can choose microservice, just a basic one, and then I have some language options. So you can see here we've got Java with MicroProfile / Java EE, we've got Node, Python, and then also Java Spring as well. So I'm going to go for the MicroProfile Java EE one, enter a name, so if I call it JAX London demo, and then that will create my project. I'm finding because of the conference Wi-Fi that takes a little bit longer than I want to show you in a demo, so I'm going to switch to one that I did earlier over here. So this is my application here. I can actually open it in VS Code as well to have a look at the code. And you can see you get a whole project here. So you get some things to deploy to IBM Cloud. You get some charts if you want to use Helm and Kubernetes. You get your actual application itself. And you do also get a Docker file. So this is the Docker file that we've got here. You can see it's based from WebSphere Liberty, and we're copying in some config and then running it. And we also have a POM file down here as well. So if I go back to my application, I can run npm install. So this will build my application. It will compile all of the code. it's actually going to start up my server as well. So this is running with a Liberty server under the covers. So you can see it starting the server there, and it's going to run integration tests against that Liberty server, make sure everything's happy. Then it will stop the server and create a package that I can then run somewhere else if I want to. So for now, I'm not going to push this up to IBM Cloud or anything. Instead, I'm going to run it locally with Docker. So if I do a Docker build and tag it JAX London, then this will just build that Docker file that I showed you a minute ago. And you can see it there building up the different layers. And then I'm going to run the container. So I could just run it now and access it, and my application would be there and running. But if I'm developing locally, then I might want to make some changes without having to restart my Docker container. So in order to do that, I'm actually going to run it mounting a volume. So I do a Docker run, specify some ports. So in this case, I want it running on 9080, so that's the default port for Liberty. And then I'm going to specify a volume. Now the location for my volume is the contents of my server. So in this case, it's in the target directory of my application. So in target, I've actually got a whole Liberty server that's been pulled down as part of my Maven install that I did a minute ago. So in WP user, servers, default server. And then I'm going to map that to a /config directory. So the config directory is something that comes with the Liberty Docker file, and if I put config there, then it should get picked up by the server. And I want to run the JAX London one. So that will start up my application. You can see WebSphere Liberty starting up there, and it should pick up all of my application that I built and my server config. So there you go, you can see it says it's ready. So I should be able to hit initially the health endpoint that is provided by my application. And that should show the application running. So you can see status is up. And then I can also hit an example endpoint that I have been given. So if I decided to add Cloudant, then the example endpoint might come with some connection to Cloudant as well. But in this case, you can see it just says some data. So if I then want to make a change, I can go to my application over here, update the example Java page, change this to say hello from JAX London. Save that. And if I had VS Code set up, then I could actually get it to rebuild my application as part of VS Code, because Liberty Maven plugin has the capability to do that. But in this case, I'm actually just going to run npm package again. So you can see my other one that I was creating has actually finished. But if I go into my JAX London one, and then run npm package, assuming I've set up my volume correctly, we should see this get updated. So you can see there, the build's finished over here, and you saw the server pick up the application. So because the Liberty server will pick up actual application changes as well as the config changes that Graham showed, it's then updated my application. So then if I go back and hit this endpoint again, now it says hello from JAX London. So that's just kind of a demonstration of where you can use Docker, which means you can get development and production parity, but it doesn't restrict you from having a nice developer experience locally. Okay.
What's next?
So that's just some slides, some screenshots from my demo in case it didn't go very well, but it went well, so that's good. And now I'm going to talk about packaging.
Okay. Yeah. All right. So we've seen examples of app servers that support EE technologies and how they can be appropriately right-sized for doing microservices. We've seen Docker, how Docker's kind of a core component for doing microservices. So now I'd just like to talk a little bit about packaging. So it's not just the case that you perhaps want to just produce a single unit with absolutely everything thrown into your Docker container and work with that. you need to think about what the capabilities are you want of your packaging. So do you want it to be externally configurable? Do you want your packages to be immutable? Do you want them to be maintainable? I think most people want the things they create to be maintainable. Consistent, so consistent as you go through the pipeline. Do you want to maximize reuse and sharing between your microservice deployments? Do you want a clean separation between application and middleware? And I think this is an important one that isn't really considered as much as perhaps it should be. And also you need to think about organizational fit. So who here has separate development and operations teams in their organization? Yeah, quite a few. I see that quite a lot, and that kind of, to some extent, goes a little bit against where the kind of industry is evolving to in terms of microservices. We see a big push for having the people who create the microservices being responsible for the operations, and I think that's quite nice, because in doing so, you perhaps as a developer take a little bit more care over the kind of serviceability and maintainability of that service, given it's you that might get called out in the middle of the night. But if your organization isn't like that, then that potentially impacts what you do in terms of packaging. So there are a number of options. There are wars. Maybe you just build a war file, and with organizations that have separate dev and ops teams, then that's quite often what you need to do. You need to just build what you've been building in the past, and then give that over to the operations team, and hopefully the operations team are evolving what they do in terms of how they do deployments to be more appropriate for the requirements of microservices. What Docker does, as we talked about with the layering, is gives you the opportunity to not only describe the architecture of how things are built up through the layering. So in this example over here, I've said build up from the base OS, add Java, add your server capability. Maybe you've got teams that are producing frameworks that your applications are built on. So you might want to insert another layer there to cover those frameworks, and then finally have your applications on top. So think about that in terms of how you architect your containers, because if you go that route, that's going to give you maximum sharing across the different deployments. We see it's very popular at the moment to do runnable jars, and all the environments that kind of, or most of the environments enable you to produce runnable jars. So Spring Boot, Liberty, Pyara, Wildfly, and so on. So you can go down that route. However, that route makes it a bit more difficult. If you're going to put those things into a Docker container, it's more difficult to get that sharing and reuse, because they tend to just pull everything into that jar file and make that one executable. So you're only going to be able to share maybe the base OS and the Java layer in that case. And another consideration is, as I said, most microservices deployments are polyglot. So making a runnable jar, does that really make that much sense in an organization that's just going to be deploying Docker containers anyway?
Okay. So now I'm going to talk about OpenAPI. So does anybody already know what the OpenAPI specification is? If I say it's somewhat related to Swagger, have people heard of Swagger more than they have OpenAPI? There's a few more nods. So it's a simple, standard API description format. There's sort of two versions. The first version was released October 2014, and back then it was known as Swagger, and then that was sort of donated into what is now the OpenAPI specification, which version 3 was released July 2017. So there's various different people who support it. Swagger I already mentioned, and you'll find it's also supported in various application servers. So for example, Liberty and Wildfly Swarm as well. So why am I talking about it? Why would you want to use it for microservices? Well, when it comes to microservices, communication between your services is a key element to getting an application that functions well. And often when we have microservices architecture, the different microservices in one application will be created, developed, deployed, managed by individual teams. And so it's very important that the APIs that they expose and the communication between those microservices is well documented. If it isn't, then you will get into a situation where one team has one idea about what the API should look like, and then another team has some different idea. And even if everyone gets around a table and discusses it, unless you have it written down, you can't be 100% sure that you all agree. Another reason for looking at the OpenAPI specification is for testing. So when you're deploying your application, you want to know that your API that you're exposing isn't breaking any of the consumers. The microservices in your application want to work very well together, and if your update breaks someone else, then you're going to have problems. And you can use tools like Pact as an example, which will actually create tests and help you manage that set of APIs and make sure that when you update your API, you're not breaking any of the consumers. Microservices is also driven by a desire for short life cycles. So I've talked about wanting to update your applications and getting them out there more quickly. And that means you're actually going to be writing applications more frequently, probably, than you would have done before. Which means actually being able to auto-generate some of the code is really useful. And there's actually various different ways that you can do that if you're using the OpenAPI specification. The other thing to keep in mind is we've talked a lot about how your microservice may well be polyglot and the different services can be running in different languages. And actually, if you're using OpenAPI, then you'll find that it works well with many other languages. So I know in some of the work that I've done, we've had other teams that are writing microservices in languages like JavaScript or things, and they're quite happy to use the OpenAPIs as a way of defining our APIs. So for code generation, there's some open source tools that you can use. If you go to Maven and look for the OpenAPI specification, there's loads of different modules that you can use and dependencies that will help you either generate your tests or generate your code or generate the actual documentation itself. And there is built-in vendor support. So the IBM Cloud provides vendor support built-in support, for OpenAPI. You can actually go there and pass in a specification, it will produce some code for you. And we have a similar capability in the Liberty App Accelerator, which, if you haven't heard of it, it's similar to start.spring.io that you might have seen, or the Wildfly generator, I think it's called. You pick some different technologies and then you can generate an application. So similar to the BX Dev Flow, but with the UI, and it's Liberty specific. Also, as I said, the Wildfly Swarm project generator, which is similar to App Accelerator, provides Swagger generation capability. So this is an example of what you might get if you were using WebSphere Liberty. So you have your endpoints over here, and you can supply some annotations. A lot of the OpenAPI specification in Java is annotation-driven, so you can actually have the annotations that influence your documentation right there with your code. And the advantage of this is that when you come to change the API, it's easy to remember to change the documentation because the annotation is right there next to each other. And then what you get at the end is this lovely UI here. So this is an example from an airline service. And this screen here looks very similar no matter what vendor you use. This is just the IBM version of it. And you'll actually find if you were to click on one of these buttons, you can often use a try it out feature. So you can actually click a button and try the API right there in the UI rather than having to construct calls to the API yourself. So that's a really useful feature. So, a conclusion of what we've kind of covered. You should consider the individual capabilities in Java EE. You may find that for your microservices, there are very useful features in Java EE. You just might not want all of them, but many vendors now allow you to pick and choose exactly what you want to use. You should choose the runtime to fit your capability needs. And if you use Docker, then actually having a jar file potentially is just a distraction. So don't just think about what you're initially building as part of your app, but think about where you're deploying it as well and whether that is into a containerized environment. MicroProfile adds programming model essentials and removes kind of boilerplates. So a lot of the specifications that they're bringing in, things like config, are just set up using annotations. So it's not a lot of code to add, but it gives you a lot of capability. And the Swagger or OpenAPI specification is really useful for polyglot API management. So even if your microservices aren't all written in Java, it's still something that you can make good use of. We've also got some resources for you to go and learn more. So I co-authored a IBM Red book about microservices best practices for Java. So you'll find some of the things we mentioned in this presentation in there. And if you want to go and learn more about Liberty with microservices, wasdev.net is the developer site. So all of the blogs and documents up there have actually been written by Liberty developers. So me and Graham have written a few of those. We haven't mentioned Microservice Builder yet, I don't think, in this presentation. So Microservice Builder is a set of capabilities to allow you to run on the IBM Cloud Private with Java and with Liberty. Graham can probably give it a better explanation than I can. But it does also link into the BXDev experience that I showed. So you can actually get similar, the application that I generated today runs well on Microservice Builder, and it's also available through App Accelerator. Then we have openliberty.io, which is the site if you want to go and find more about OpenLiberty, and then of course MicroProfile.io, which has all of the details about the MicroProfile initiative. Also linked some books and some blogs that you can check out. Some of them, the bottom two, have been around for a bit longer, but actually the ideas in there are still very applicable to microservices and are very useful. So thank you very much for listening, and we'd welcome any questions.
I have one question. You showed slide with metrics and health checks and configuration for MicroProfile.
Yes.
And also you talked about the fact that microservices actually are polyglots, are designed to have different technology in the stack. How those two play together? I mean, can you integrate it together to have more integrated metrics and health checks and configuration, or it is meant to be only for MicroProfile and Java part of stack?
So those specifications define, they essentially define APIs, REST APIs that you can expect from MicroProfile vendors. There's no reason why they couldn't be implemented on other technologies because they are just REST APIs. So you could implement them in Node, you could implement them in Swift or Go or whatever you liked. It's early days for those, so they're quite basic capabilities at the moment, but hopefully they'll evolve over time and maybe get adopted by other environments and then adopted by maybe administration capabilities. Yeah.
And about the metrics, is it somehow related with the format that Kubernetes is using, so the Prometheus-like metrics, or is it totally different?
It only defines a small core set of metrics, and then it's extensible. So you could, if you wanted, provide that information through that API, and it's up to the environment's implementation choice.
Okay, thank you.
Yeah. Okay.
Yeah.
About an OpenAPI, this is for documenting REST, right?
Mm-hmm.
So does it already support HALOs or
Support.
HUOs?
So I was in a talk yesterday about that, and the assertion was that it doesn't. I don't know enough details about OpenAPI to know whether it does or not. There are pros. So that was a talk about I think the Spring capabilities, and there are pros and cons to each approach. I think OpenAPI is more of a polyglot answer. Because it's not tied to any specific language or runtime environment or anything like that, and it gives you an API definition that you can then use the generators to generate clients for different languages and so on. But specifically and pronouncing this is difficult, HATIOS or hypermedia. On that specific topic, I don't know enough details to know whether what was discussed yesterday is the case.
Any other questions? we'll be hanging around a bit at the end and at the IBM booth
Yep.
for a little bit afterwards, so feel free to come and say hi.
Thank you.